Hey there, all you cats and kittens. You ready to go and do a review on 5.1 Antiderivatives, otherwise known as integral review. We're going to go over the general solution of functions, and we're going to go over the particulate solution when you actually find out the value of C as well. We just pretty much went over this lesson in the last lesson, and it's only a quick little test on what we have to do. So let's get started. Really quick, basic integration rules. Integral of 0 is C, the constant. Integral of a constant, such as 1, would be that constant x plus c. So the integral of like 6 would be 6x plus c. Integral of a constant times a function, you would just multiply that integral of the function times the constant. You add them together. Integral of e to the x is e to the x plus c. Integral of 1 over x is ln x plus c. Here's the trig functions, integral of cosine sine, and this is all plus c's, I just don't usually say it. Integral of sine is negative cosine, whoops. Integral of secant squared x is tan x, secant x tan x is secant x, cosecant squared x is negative cotangent x, and cosecant cotangent becomes negative cosecant x. They're just the opposite of the derivatives. And then once again, the power rule, when you take the integral of a variable to a power, is that variable to the power plus 1 over whatever that power is plus 1. Plus c, where n can't be 1. All right, so let's get going. Need my little pointer here. And try problems 1 and 2. All right, hopefully you guys got the answer. You are using the power rule and the constant rule. Remember the power rule, you're going to take the variable, you're going to add 1 to it, and you're going to divide by that same number. Now the constant just comes out first. So if you want to separate it, you can. You don't have to. So you have an x to the 5th and x and just a dx all by itself. That becomes x to the 6 over 6. That becomes x, 1 plus 1 is 2, x squared over 2. And since there's nothing here, it's actually technically a 1, which is the placeholder, so it's just 8x plus c. All right. 4 over 6, you're going to reduce that. 4, 6, 9 over 2. All right, 9 halves plus 8x plus c, and this can be reduced. You can divide both of these by 2, giving you 2/3 x to the 6 plus 9 halves x squared plus 8x plus c. See how easy that is. Let's look at problem number 2. Got your answer? Good. Once again, pull out the negative, the 6, and the 21. Okay, if you choose to do so. 10, 6, 2. So negative x to the 10th over 10 plus 6 times x to the 6th over 6 plus 21x squared over 2. All right. This just becomes negative 1/10. 6 divided by 6 is 1. And 21 divided by 2 is 21 divided by 2. And there's your answer. Plus c. All right. Problem number 3. There's a step you have to do before you integrate it. And that step is to distribute. So you're going to distribute it. You add exponents when you multiply them. 2 plus 5 is 7. 2 plus 2 is 4. And then you get your x squared. All right, and then 3 times all the numbers. So now you're going to separate it once again. Pull out the 3, the 9, and the 213. 8, 5, and 3. See, you're just adding 1 to it. 3 times x to the 8th over 8 minus 9 times x to the 5th over 5 plus 213x cubed over 3. 3/8, 9/5, plus c, and 213 over 3. 213 divided by 3 is actually 71. If you want to do that in your head, 210, 21, divided by 3 is 70. 3 divided by 3 is 1. A little mental math for you. There you go. How we doing? You're doing good? Hopefully we are. Problem number 14. Basic concept, but instead of distributing, we're going to split this up and divide all 3 of those things by the denominator, which is x cubed. You can also multiply and distribute an x to the negative 3n if that is what you prefer. When you divide exponents, you subtract. 9 minus 3, 3 minus 3, 1 minus 3. So you get x to the 6th, cancels out, just leaving it at 7. 1 minus 3 is a negative 2. You have 2 more x's on bottom, that's why it's x to the negative 2. Now, you got to this point, same exact equation. Separate, take out the 17, the 7, and the 8, add 1, up, add an x, add 1. 7 okay, over 7. This becomes 7x. And negative 2 plus 1, negative 2 is here. When you add 1, you go to the right. So that's actually a negative 1. So it's 8x to the negative 1 over negative 1 plus c. Can't reduce. That just becomes negative. So 7 over 17, x to the 7th plus 7x minus 8x to the negative 1 plus c. If you want to make this minus 8 over x, perfectly okay. All right, there we go. First 4 problems. Oh, there we go. All right, let's go look at number 5. Ooh, we got a lot of space here. So when you try this one, now I'm going to give you a hint. Did you start it? Did you do it good? You can use the same rule. Now, another rule you have to use is this rule right here. 1 over x to a power is x to that power, x to that negative power. So for instance, like 5 over x to the 8th would be 5x to the negative 8. All right, so try again if you didn't do that. All right, so did you rewrite it? This becomes 5x to the negative 7th, 18x to the negative 3, 31x to the negative 2, and it stays 42. Now it's easy. Separate. Take out the 5, negative 18, negative 31, and negative 42. Or you can leave the negative 42 in there. Doesn't matter. I don't know. I usually leave it in. Negative 7 plus 1, remember you're going this way. So when you add 1 to negative 7, you get negative 6. Add 1 to negative 3, you get negative 2. Add 1 to negative 2, you get negative 1. And this just becomes 42x plus c. All right. 5 over negative 6, or negative 5, 6. Negative 18 divided by negative 2 is a positive 9. Negative 31 divided by negative 1 is a positive 31. 2 negatives is a positive. Minus 42x plus c. And that's it. Was that easy? I think so. You try another one? Of course you do. Let's go problem number 6. Now, if you prefer to write all your x's back on the bottom, you may. Either way will give you the correct answer. Okay? I prefer this way. Some people prefer that way. Whatever you prefer is correct, as long as you got the same numbers. All right. Using the same power rule. But what do we have here? 8 over x. So we have to use another rule. Think back to that first slide I showed you. So you get 22 x dx. Well, this one's easy. That's x squared over 2. But 1 over x, x to the negative 1, negative 1 plus 1 is 0. So x to the 0 would be 1. So this can't be 1. Do you remember what rule to use? Integral of 1 over x dx equals ln absolute value of x plus c. So this just transforms into that. All right, this transforms into this. This becomes this, plus c. 22 divided by 2 is 11. X squared minus 8 ln absolute value of x plus c. That's it. You didn't need all the space, but I had extra pages on the packet. That's why I threw it in. You all good? Awesome. 7 and 8, go. All right, that's it. Oh, what's the integral of e to the x? So you got 1/3 e to the x, x to the 7/4 x plus 1 dx. Sorry, minus. Integral of e to the x is e to the x. So this becomes 1/3 e to the x plus 11. 7 over 4 minus 1 is 7 over 4 minus 4 over 4. So, plus 1. 7 over 4 plus 4 over 4. 7 plus 4 is 11. And the denominator says 4. So 11 over 4 divided by 11 over 4. Minus 1 times x plus c. Now when you do this, you have to do the reciprocal. Okay? The reciprocal of 11 over 4 is 4 over 11. So 11 times 4 over 11 is 44 over 11. Oh, there we go. There, I did my reciprocal. 4 over 11. Now, 11s cancel out, leaving you with just a 4. Or you can do 11 times 4 is 44, divided by 11 is 4. But the 1/3 e to the x stays. This becomes this, minus x plus c. Okay, remember, when you do this, you have to multiply by the reciprocal. So the 4 pretty much jumps to the top. Got it? Trickiest thing is fractions. Seniors should be able to do fractions. This one, you got to use some trig functions. Let's look. All right, you got the integral of cos. Take out the 7, secant x tan x. So look back to that first page. Everyone over? Integral of cosine we know is sine. Pretty much plug and play. Integral of secant tan is secant plus c. That's your answer. Sine x minus 7 secant x plus c. All right. Easy lesson, simple lesson. All right, for the last 1, 2, 9, 10, 11, which would be 3 problems, we're going to go find the particular solution. So now you're giving an x value and a y value, or an x and an f of x. So you're going to actually find the value of the equation or the function at a particular point. Okay, so this means when this point right here would be 2, 7. Okay, so that's how that works. First step, once again, is to integrate. Pull out the 10, x to the 4th, 6x squared. Then you add 1s. 10 times x to the 5th over 5 minus 6x to the 3rd over 3. 10 divided by 5 is 2. 6 divided by 3 is 2. So plus c. So you got 2x to the 5th minus 2x to the 3rd plus c. So once you find your integral, like we did for the first 8 problems, now what you're going to do is you're going to take this and find out what your x and f of x is. Now your x is the number that's in here because it's f of x. So your 2 is your x, and it's f of x equals 7. So now you got these two things. F of x, the 7, goes here. X equals 2, goes in here and here. So you got 7 equals 2 times 2 to the 5th minus 2 to the 3rd plus c. Now, this is not 2 times 5. This is 2 times 2 times 2 times 2 times 2. All right? So it's 2 times that, which is 32, minus 2 times 2 is 4 times 2 is 8, plus c. 64 minus 16 plus c. Now, 64 minus 16 is 48. Now, in order to solve for c, you subtract 48 from both sides, and you get a negative 41. So that is the value of my c. Since I have the value of my c now, what I'm going to do is plug it in here, and that's my answer. 2x to the 5th minus 2x to the 3rd minus 41. See how easy that was? And I know most of you got that right. Problem 10. Go. All right, I'm sure most of you got it right. Are you excited to see if you got it? Rewrite it. 2x to the negative 7th. Remember the rule? Variables on bottom, make it a negative exponent. You move it to the numerator. Negative 7 plus 1 is negative 6. So it's 2 times negative 6 over negative 6. 2 divided by negative 6 is 2 over negative 6. You can take out a 2, and you get, negative 1/3 x to the negative 6 plus x, or x to the negative 6 plus c, over 3 plus c. Sorry, sometimes early morning. Now, 1, I like to pull the negative out, and I'm going to put this x to the 6th on the bottom. All right? Since this is negative, if I move it to the bottom, it becomes positive. Okay? Took this negative, just drag it forward. If you want to leave it like this, there's no harm in it. This looks a lot nicer. It'll be easier when we do our problem. All right? Now, f of x is negative 10. X is 1. So f of x equals this. So negative 10 equals negative 1 over 3 to the 1 to the 6 plus c. 1 to any power is what? 1. So negative 10 equals negative 1 over 3 times 1 plus c. 3 times 1 is 3. Negative 10 equals negative 1/3 plus c. You add 1/3 to both sides. Negative 10 plus 1/3 is not negative 10 1/3. It's negative 9 2/3. Okay, because you're doing opposite signs. That's my c. My c goes back in over here. So f of x equals negative 1 over 3 x to the 6 plus a negative 9/2. So we can just put minus 9/2. 9 2/3. Sorry. You could also put negative 29 over 3. What else could we put? We could put negative 9.6 repeating. All right. Got it. Negative 1/3 x to the negative 6, if that's what you want to go with. All those are good. Ready to do the last one? Last problem. Ooh, do you remember to rewrite the fraction? That should be written as x to the 3/4. So whatever is in here is the numerator. Whatever is before your radical bar is your denominator. So now that we got that, what we're going to do is we're going to subtract, we're going to add 1. 3/4 plus 1. 3 over 4 plus 4 over 4. 3 plus 4 is 7. So you got x to the 7/4 over 7/4. When you divide by a fraction, you multiply by the reciprocal. Reciprocal of 7 over 4 is 4 over 7. And we can leave it like that. X equals 0. F of x equals 18. Good? So, f of x equals 18 equals 4 over 7 times 0. Ooh, can we have a 0? Of course you can, as long as it's not in the denominator. Now, 0 to the 7/4 is 0 to the 7th power is 0. The 4th root of 0 is 0. So that's 0. 4/7 times 0 is 0. So C is 18. Got it? 4/7 x to the 7/4 plus 18. And that concludes our lesson. Shouldn't be a very difficult test. As you can see, this is fairly simple. Hopefully you guys do very well. And good luck. And if you have any questions, make sure you email me.